This is SpaceTime, Series 27, Episode 122, for broadcast on the 9th of October 2024. Coming up on SpaceTime, the Sun unleashes its most powerful solar flare in more than a decade. A new study shows the dwarf planet Ceres may have once been an ocean world. And NASA's Europa Clipper mission slated for launch tomorrow. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Sun has just emitted its most powerful solar flare in more than a decade. It was one of a pair of solar flares that erupted just 2 days apart, which were the most powerful in the current solar cycle. The biggest was a spectacular X9.1 class event, which hit close to the top of the energy scale, and it hurled a coronal mass ejection directly towards the Earth. The powerful blast was generated by the same AR3842 sunspot group, which had earlier launched an X7.1 class flare, the second strongest solar flare of the current solar cycle. Both were detected by NASA's Solar Dynamics Observatory spacecraft. The X7.1 class event hit the Earth on October the 4th as a mild halo coronal mass ejection, and the more powerful X9.1 blast hit on October the 6th. The dual impact sparked strong G3 class geomagnetic storms with auroral activity reaching mid-latitudes. Radiation from the flares ionized the top of Earth's atmosphere, causing deep shortwave radio blackouts. Solar flares are powerful bursts of energy flung out into space as magnetic field lines from deep inside the Sun erupt out above the Sun's surface along sunspots and then snap, releasing energy in the process. These events' classification as X-class flares indicate they're the most intense type of solar flare that's produced, while the numbers provide more information about their strength. Solar flares are classified on a logarithmic scale, similar to earthquakes and tornadoes. If the events are strong enough, and these two were, they can drag solar plasma and magnetic field into space with them. That's a coronal mass ejection. These space weather events, known as geomagnetic storms, can damage or even destroy spacecraft, or at least they can shorten their lives by causing the Earth's atmosphere to expand, and that increases atmospheric drag on the spacecraft. That causes orbital decay, forcing the satellites to use up more of their reserve fuel in order to maintain an operational orbit. Geomagnetic storms can also disrupt communications and navigation systems. They black out power grids on the ground by overloading transformers. And they can increase radiation levels for astronauts and even people in high-altitude aircraft. Of course, on the plus side, they cause spectacular auroral light displays, usually at higher latitudes, as the charged particles they bring travel along the Earth's magnetic field lines and excite atoms and molecules in the atmosphere, triggering the aurora borealis and aurora australis, the northern and southern lights. Our Sun's currently experiencing a massive increase in solar activity as it moves towards the climax of its 11-year solar cycle. The current solar cycle, number 25, began in 2019 and should reach solar maximum, that's the climax of the cycle, sometime in the next year or so, at which point the Sun's magnetic poles will quite literally flip polarity, with the North Pole becoming south and the South Pole north. That won't be the end of the solar storms, but gradually over time they will start to decrease again until they reach solar minimum sometime around 2030. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, a new study claims the dwarf planet Ceres may once have been an ocean world, although probably a somewhat muddy one. And NASA's Europa Clipper mission to the Jovian ice moon slated for launch tomorrow. All that and more still to come on SpaceTime. A new study claims the dwarf planet Ceres may once have been an ocean world that slowly morphed into a giant muddy icy orb. Since its discovery in 1801, astronomers and planetary scientists have pondered the makeup of this distant frozen world, which is the largest body in the main asteroid belt between Mars and Jupiter. The 950-kilometre wide dwarf planet has surface features like volcanoes, landslides and glaciers, and a heavily battered and dimpled surface covered with impact craters. And that suggests the world hasn't been resurfaced in recent history, and therefore it couldn't have been very icy in the past. However, a new study reported in the journal Nature Astronomy suggests that Ceres has a rather dirty icy crust, meaning it may once have been an ocean world, if a somewhat muddy one. The findings are based on new computer simulations, which examined how craters on Ceres deformed over billions of years. One of the study's authors, Mike Sorry from Purdue University, says there appears to have been lots of water ice near Ceres' surface, and that it appears to get gradually less icy the deeper and deeper you go. Sorry says people used to think that if Ceres was very icy, the craters would deform quickly over time, like glaciers flowing on Earth, or like gooey flowing honey. However, these new simulations have shown that ice can be much stronger in conditions on Ceres than previously predicted if you mix in just a little bit of solid rock. The team's discovery is contradictory to the previous belief that Ceres was relatively dry. The common assumption was Ceres was less than 30% ice, but Sorry's team now believes the surface is actually more like 90% ice. Sorry says Ceres used to be an ocean world like Europa, the Jovian ice moon, which contains a global subsurface liquid water ocean beneath its frozen crust. However, Ceres had a dirty, muddy ocean. As that muddy ocean froze over time, it created an icy crust with a little bit of rocky material trapped in it. Now, even solids will flow over long timescales, and ice flows more readily than rock. Craters have deep bowls, which produce high stress levels and then relax to a lower stress state, resulting in a shallower bowl thanks to a solid state flow. So, the conclusion after NASA's Dawn mission was that due to the lack of relaxed shallow craters, the crust couldn't be very icy. However, the new computer simulations account for a new way the ice can flow with only a little bit of non-ice material mixed in, and that would allow a very ice-rich crust to barely flow even over billions of years. And in that way, you could end up with an ice-rich Ceres that still matches the observed lack of crater relaxation. To reach their conclusions, the authors tested different crustal structures in their simulations. They found that gravitational crust with a high ice content near the surface that grades down to lower ice with depth was the best way to limit relaxation of Sirian craters. Back in September 2007, NASA launched the Dawn mission to visit Ceres and another main belt asteroid called Vesta. It was the first spacecraft to go into sustained orbits around two separate extraterrestrial destinations. Dawn arrived at Ceres in 2015 and remained in orbit studying the dwarf planet until 2018. The authors used multiple observations made by Dawn to provide the data they needed for their simulations. Different surface features such as pits, domes and landslides all suggest that the near subsurface of Ceres contains lots of ice. And spectroscopic data also shows that there should be ice beneath the regolith on the dwarf planet, and gravity data yields a density value near that of ice, specifically ice loaded with impurities. The authors also took a topographical profile of an actual complex crater on Ceres and used it to construct the geometry for some of their simulations. Sorry says it all points to the dwarf planet having once been a frozen ocean world, pretty close in many characteristics other than size to the planet Earth itself. This is SpaceTime. Still to come, NASA's Europa Clipper mission, slated for launch to the Jovian ice moon tomorrow. And later in the science report, researchers have for the first time mapped the entire brain of Drosophilus, the fruit fly. All that and more still to come on SpaceTime. NASA's Europa Clipper mission is slated for launch to the Jovian ice moon during a 21-day launch window which opens tomorrow. The 3,241-kilogram spacecraft is the largest planetary mission ever undertaken by the space agency. It'll launch from the Kennedy Space Center in Florida aboard a SpaceX Falcon Heavy rocket comprising 3 Falcon 9 core stages mounted side by side. If all goes well, the spacecraft will reach the Jovian system in April 2030. On board will be 9 science instruments designed to understand the nature of this 3,120 kilometre wide frozen world and the global liquid ocean beneath its icy crust. The mission is designed to help scientists better understand the potential for life on other worlds. Its instruments include a mapping imaging infrared spectrometer that'll map ices, salts and organics as well as warm spots on Europa that could be suggesting habitability. It'll also reveal how material is exchanged between the surface ice and the ocean below. There's a tetracorder which will provide rapid analysis of Europa's composition. A thermal emissions imaging system will map the temperature and texture of Europa's surface, looking for clues about activity such as icy geysers and regions where the moon's suspected ocean may be nearer the surface. There's an ultraviolet spectrograph which will study Europa's atmospheric and surface composition. It'll provide special focus on the plumes that may be erupting from the ocean beneath the ice. Its measurements are especially sensitive to detecting vapor plumes that could be difficult to spot using other techniques. The instrument will also study interactions between Europa's thin atmosphere and charged particles in space. These interactions can make Europa's atmosphere glow in ultraviolet, very much like aurorae on Earth. Then there's the Europa imaging system. It'll use visible light cameras to generate high-resolution maps of Europa's surface, covering about 90% of its surface at 100 metres per pixel. That equates to 6 times more of Europa's surface and 5 times better resolution than has ever been captured before. And when the spacecraft makes a close flyby of Europa, the instrument will produce images with a resolution 100 times better. Its three-dimensional views will also allow scientists to measure surface heights, and its colour images will provide information about Europa's surface material. Another part of the spacecraft's scientific package is a dual-frequency ice-penetrating radar instrument. It'll characterise and sound Europa's icy crust from near the surface right down to the ocean, in the process revealing the hidden structure of Europa's ice shell and potential water pockets within it. It'll also probe the exosphere, the surface and near surface, and the full depth of the ice shell itself, right down to the ice-ocean interface, which could be up to 30 kilometres deep. The Europa Clipper magnetometer will be used to characterise magnetic fields around Europa using 3 magnetic flux gates placed along an 8-metre boom, which will be stowed during the launch and then deployed once in flight. By studying the strength and orientation of Europa's magnetic field over multiple flybys, scientists hope to be able to confirm the existence of Europa's subsurface ocean, as well as characterise the thickness of its icy crust and measure the water's depth and salinity. There's a plasma magnetic sounding instrument aboard as well. It'll measure plasma to characterise the magnetic fields generated by plasma currents. These plasma currents match the magnetic induction response of Europa's subsurface ocean. And in conjunction with the magnetometer, it'll be key to determining Europa's ice shell thickness, ocean depth and salinity. It'll also probe the mechanisms responsible for weathering and releasing material from Europa's surface into the atmosphere and ionosphere and understand how Europa influences its surrounding space environment and Jupiter's magnetosphere. There's a mass spectrometer that'll determine the composition of the surface and subsurface ocean by measuring Europa's extremely tenuous atmosphere and any surface material ejected into space. There's also a dust analyzer, another type of mass spectrometer, that'll measure the composition of small solid particles ejected from Europa. That'll provide an opportunity to directly sample the surface and potential plumes during low-altitude flybys. This instrument's also capable of identifying traces of organic and inorganic compounds in the ice ejector. Finally, Europa Clipper will use its radio antenna to perform additional experiments and learn more about Europa's gravitational field. You see, as the spacecraft performs each of its 45 flybys, its trajectory will be subtly altered by the Moon's gravity. Now, by sending radio signals between the Earth and the Moon and characterising the Doppler shift in the return signal, scientists should be able to create a detailed characterisation of the spacecraft's motion. And that data will help determine how Europa flexes in relation to its distance from Jupiter, which in turn will reveal information about the Moon's internal structure and its tidal motions. This report on Europa Clipper by NASA TV.
Everywhere on Earth that there's water, there's life. We have several ocean worlds in our solar system, and by exploring Europa, we're getting a taste of what these ocean worlds are like.
Europa is one of the moons of Jupiter. It's about about the same size as our own moon, a little bit smaller, but it's so much different. It's an ice world.
Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
When we first discovered hydrothermal vents on our seafloors on the Earth, we also discovered life. There was no sunlight that was penetrating down that deep, but yet there was life living there.
On Europa, we're not looking for life itself, we're just looking for an environment in which life could thrive.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are very few, shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there is plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
The Europa Clipper mission will be the first in-depth exploration of an ocean world.
Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa. And the main reason it's doing that is to stay mostly outside of Jupiter's really intense radiation belts.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near infrared, the far infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials, maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. We're looking for signs of organics at Europa. Are there materials that contain carbon and hydrogen and oxygen and nitrogen? And we have another instrument that can tell us the composition of dust particles. We're pretty sure there are salts on Europa's surface, and those salts may have come out of the ocean. We want to understand what are those salts.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
So there really has not been a mission like Europa Clipper. The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
I have no idea what we are going to detect beneath Europa's icy surface, but all I know is it's going to be wonderful.
We do this work of exploration for the next generation. We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And in that report from NASA TV, we heard from Europa Clipper project scientist Robert Pappalardo from JPL, Europa Clipper deputy project scientist Bonnie Buratti, Europa Clipper staff scientist Katie Kraft from the Johns Hopkins Applied Physics Laboratory, Europa Clipper staff scientist Aaron Leonard, also from JPL, and Europa Clipper investigation scientist Sean Brooks. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. New figures show that more than 47,000 people suffered heat-related deaths across Europe last year. The findings, reported in the journal Nature, are based on a modelling study by international researchers. And they claim the figures would have been much higher if people didn't have modern-day healthcare and comforts like air conditioning. The authors reached their conclusions based on death data from the European Statistical Office. That allowed them to estimate heat-related deaths in 2023 across 35 European countries. The figures suggest that 47,312 heat-related deaths may have happened between May 29th and October the 1st, 2023, with the highest number of heat-related deaths occurring in southern Europe. The authors then estimated what the death rate would have been without modern-day advantages. That suggests that the heat-related death rates across Europe could have been 80% higher in the general population and 100% higher in the elderly. A new study claims a mysterious type of iron-rich magma entombed within extinct volcanoes is likely to be abundant in rare earth elements. The findings, reported in the journal Geochemical Perspectives Letters, could offer a new way to source these metals. Rare earth elements are important to modern society. They're found in everything from smartphones and flat-screen TVs through to magnets, trains and missiles. They're also vital for the development of electric vehicles and renewable energy technologies such as bird-killing wind turbines. Scientists have for the first time mapped the entire brain of Drosophila, the fruit fly. A report in the journal Nature claims this new map can teach researchers about brain function. The authors say the fruit fly brain has around 140,000 neurons and more than 50 million connections. That's around 1 million times fewer neurons than most human brains. They say despite its size, the fruit fly brain is still used for a range of complex behaviours by the insect, and that makes it an ideal starting point to help them towards their eventual goal of mapping other species, including the human brain. There'll be a new update for Windows 11 coming out next month. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, this is called the Windows 11 24H2, so the second half of 2024. And normally these things are not always bringing new features. I mean, sometimes they are, obviously there's bug fixes, but this time if you have a Windows Plus Copilot PC, which is one of the new ones with the chip inside that does the artificial intelligence with the neural processing unit, you'll get the new recall feature in preview, which takes screenshots of everything that you're doing and allows you to search through those screenshots and actually interact with them. You won't have to bring up the actual Word or PDF document, for example. You can copy and paste text and copy images from it, but you'll now have to have Windows Hello or your fingerprint or a password to enable access to that. Nothing is meant to be going back to Microsoft, and there's additional features inside that basically take advantage of the fact that your AI chip can sit there and help you to remember things and find things that a normal search cannot. And you can also pause the recall feature if you're going to sites where you don't want it to remember anything, maybe your banking site, for example, or other sites that you're on. And it's supposed to give your PC a photographic memory. And it's actually quite a smart idea, but the way that Microsoft rolled it out at first and basically promised security when nobody believes Microsoft can deliver a secure version of Windows, naturally people were a bit concerned about it and it got paused. And so this is meant to be coming in November, one of the big features. There's also a thing called the Click to Do feature. So this is where you can take a snapshot, like with the old-fashioned snipping tool, but now you can blur the background or erase objects maximum photo. So it's emulating some of those photo magic eraser features that we see on the Samsung and the Google phones, and even now with iOS 18 on Apple iPhones. The Windows search tool itself, in the past, took whatever you said, and if it couldn't find it, it didn't show you any results. But everybody knows if you go to Google and misspell a word, it still finds what it is you're looking for. And so the internal Windows search facility will finally get this sort of fuzzy intelligence that we're used to with using search engines. Photos and Paint, they're going to get more AI features, AI enhancements, and you can reimagine and enhance low-resolution photos, like in those CSI type shows on TV where they're improving the resolution of someone's number plate way off in the distance. Well, you'll get similar sorts of capabilities. You can reportedly increase the resolution by up to 8 times with a little slider, and the neural processing unit will do that task for you. So they're really trying to make you feel like your PC without AI features is going to be old. They want you to upgrade. And no surprise there. Everyone's doing the same thing, right? Apple's new macOS Sequoia now has a bunch of AI features built in. The Google phones are all coming with Gemini, which is their version of AI, and the use cases are coming out thick and fast. But still, for most people who haven't used it yet, they're still sort of yet to try it and see the wow for themselves. But pretty soon, every device will just come with AI as standard, and we'll have the pre-AI era and the post-AI era, and we're firmly into that now, and all the companies want you to upgrade. But of course, if you wait until next year, you get even better PC, smartphones, and tablets with even better AI features.
I had an interesting experience day before yesterday. I was organising an interview and via email, and in the email, one line I said was, I'll give you all the details in the attachment. And that was all I said. And I was just about to send it off, and then Outlook reminded me, you haven't added your attachment yet. So it was obviously watching what I was doing.
No, look, yes and no. I mean, I've seen Google do that as well. And the trigger is the word attachment. I have an attachment. And then if the email program sees, well, hang on, there's no attachment attached to this email. I mean, it says, well, hey, hang on, you mentioned an attachment in your email, but you haven't sent one. I don't think it's actually going through your email and
look, I didn't mind because I had forgotten to add the attachment, but it was still disconcerting for me.
I guess it's going to become a lot more disconcerting in the future when your computer actually is reading and understanding what it is you're saying. At the moment, it's just a trigger for the word attachment, and it's like a if-then statement. You know, if the user said attachment and there's no actual attachment file, attached to this email, then send a little pop-up to the user. And I've seen that for the last few years on Gmail, and I haven't been using Outlook for a long time because I defected to Gmail. I've been very happy ever since. But it's nice to hear that Outlook has finally caught up and is offering this as a useful service.
That's Alex Zaharov-Reut from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.